Integration by trigonometric substitutions. To use integration by trigonometric substitutions form, it is always recommended that you remember three basic identities, like sin squared x plus cosine squared x is 1 plus tan squared x is secant squared, and 1 plus cotangent squared equals cosecant squared. Now, this one is actually related to the second identity, where we can say secant squared x minus 1 equals tan squared x. The main motivation on this is, if I can put a single term inside the radical sign, I can avoid the radical sign, and that is exactly the second identity. So in this case, if we make x equals, say, 3 secant u, then what happens? X squared will be 9 secant squared u. Okay, and then we have x squared minus 9 will come out as 9 secant squared u minus 9. Now you understand that when I factor out 9, I have secant squared u minus 1. So this one is here, see that? So then this gives me single term now, sec 9 tan squared u. So when I make the substitutions in here, I'm getting x to the 4 is giving you from this will be 81 secant to the 4 u, and then square root of this one will give me now 3 tangent u. All right, from this, and then when I have x equals 3 secant u, now dx will give me 3 secant u tan u du. That we know the derivative of secant u. So then if you write it here, you get 81 times 3 secant u tan u du. Now this 81 cancelled out, this 3 cancelled out, this tangent cancelled out, and we can see that our integral is simple now, 1 over secant to the 3 now, because another secant will cancel out because we have secant u in the numerator. So it's secant cubed u du. Now this form is integral cosine cubed u du. Now we need to use another identity. Just look at here. You have sine squared plus cosine squared is 1. So then you see how we make another substitution. If you just say this is cosine squared u and then cosine u du, then we can say cosine squared will be like 1 minus sine squared u and then cosine u du. Now let us make another substitution. Another substitution is like, say, sine u is t, then cosine u du will be dt. And then we get another substitution where we have 1 minus t squared, and then cosine u du is dt. This brings me very basic form of integration where the power rule can be applied. So the 1 will give me t, and then t squared will give me 1/3 t to the 3. Now we need to substitute back what we have taken in relation to x, u, and t. So you know t is sine u. So then first you write sine u minus 1/3 sine cubed u plus a constant. But we are not done yet, because our main variable we had in x. So then we need to go back to x. Now look at here. When I have x equals 3 secant u, then I can say x over 3 is secant u. Since we are comfortable with sine cosine, then I can just say 3 over x is my cosine u. So then we make a right triangle where this angle is u, so it is cosine. So then we can say this is my 3 and this is my x. We know adjacent over hypotenuse. If this is x, this is 3, then using Pythagorean you can easily say that x squared minus 9. So then we can say sine u will be now from this right triangle square root of x squared minus 9 over x. This is my sine u minus 1/3. I have the same thing here, square root of x squared minus 9 over x to the 3 plus integral constant, and we are done.